Hello, all the JEE 2026 aspirants. Welcome to the class. Everybody, how are you? Firstly, let me know in the comment section, in the chat box, if I am clearly visible and audible to you, all of you, or not. Hi, Afzal, Ramya, GV, Rishi, Keru, Ramya, yes. Okay. Hello, Pooja. Hello. So everybody, today officially it is going to be the first lecture here because I have taken basic lectures before, and those who have not watched my lecture of concentration terms, do watch it because that is going to be very important for you. Although with concentration terms there is no direct link with today's lecture, but once we start with colligative properties, right, then the concentration terms lecture will be directly needed, right? So watch that lecture. I have taken before this class, I have taken concentration terms only, right? So everybody, firstly, let me introduce myself, right? I am Diksha Kaushal, your chemistry master teacher, and I'm going to teach you chemistry on this channel. I am BSc MSc in chemistry and BEd, and I have 8+ years of experience in NEET and JEE category. Okay, so everybody, I'm very excited for all the new students as well who have just joined here. Right? And one rule we have of our class. What is that rule? Or my old students, what is that rule? Yes, DB creation is right? Our rule is to give green hearts whenever you feel energetic. I have understood, ma'am. Then green hearts is my favorite. That's why, right? You will see, right? It's slightly green, right? Our thumbnail is also slightly green because green hearts, right, is to tell Diksha ma'am that yes ma'am, we are ready, our energy is completely high and we are ready for the class, right? Okay, yes. And for all the students who are looking for the offline centers, then students, Vedantu is situated all over India. You can see, you can look for the center near your home. And why I am telling you this thing, because at this point we are providing you IVSAT scholarship, that is 90% scholarship is going on. By registering to IVSAT scholarship program, you can avail 90%, up to 90% scholarship you can avail, right? So I would highly advise you guys to go for IVSAT registration and give this test, right? That will benefit you a lot, right? And try to give this in offline centers because the counselors will be there to help you. And if you get enrolled to our offline classes, we provide you 100% feedback, right? That is refund or your improvement. That means if you're guaranteeing you 100% refund, that means definitely we are more focused on your improvement of rank, right? And for that, we trust our teacher, we trust our high-tech classes that we provide you in the offline center, right? Okay, yes. So everybody, let us start the class without wasting any time, right? So everybody spam this chat box with green hearts, right? I want to see green hearts in the chat box, everybody. Let's get our energy high because I promise you, right? I'll take you from the basic to the advanced level, right? I promise you that, right? Even if you hate chemistry, I'm going to make you fall in love with chemistry. You just have to promise me one thing, that you will watch this session, right, with full dedication. Don't worry, this class will not be boring at all for you. You will learn something out of this. We will also do previous year questions of JEE Mains and JEE Advanced. And also, we are going to do things, right, in a very detailed manner, right? So everybody, belt up your seats here and let's fly now. Fly in the air, right? With solutes and solvents and thinking about what is exactly solutions, right? So I'm going to think that you know nothing about solutions. I'm going to teach you like that way because what I feel is a good teacher is the one who can make a student who is not able to understand anything to a topper, right? My aim is to take you from average to topper. A topper is already a topper, but to take out one average student and teach them well and convert them into a topper, I think that is the quality of a good teacher. And I definitely want you, all of you, to get your dream seat in JEE, right? Okay, yes. Duration will be same 1 hour, 1.5 hour, right? Okay, that will be it. That's it, right? But we have our target, right? I always tell students to have target based studies, but the target is going to be what? the target is going to be, ma'am, we are going to do solute, solvent, solubility. We are going to do Henry's law, Roults law. That's it. Even if you complete it in 40 minutes, class will end. If you complete it in 1.5 hour, class will end, but not more than that, right? I promise you that. Now, let us start with what exactly, and I want you guys to also chat in between, because I am actually reading your comments, be it Rishabh, be it Suga, Ramya, Rock, GV, Creation, Kevin, right, Arjun. I'm reading your comments, right? So I want all of you to be interactive in the chat box, right? So first thing is, solution is basically made up of two things. One is solute, other is solvent, right? Two things solution is made up of. One is solute, other is solvent. Now, when we think about solute, solute is the one which is in small quantities, and solvent is the one which is in more larger quantities, right? Which is in larger quantities. Now, I can't tell you that always water will be a solvent, but water is a universal solvent, right? Now, if you talk about solute, when we will talk about concentration terms, we have already done that lecture. When we'll do numericals, we will denote this solute by 2. Let's say I'm talking about the weight of the solute. I'll be like W2. I'm talking about molar mass of the solute. I'll be like M2, right? I want to calculate the number of moles of solute. I'll denote it by N2. But same, if I talk about solvent, we will denote it by 1, right? We will denote the solvent by 1. That means W1, M1, N1, mole fraction of 1. That is denoting. Whenever you see 1, that means we are talking about solvent here, not the solute, right? Now, how many of you love sugar, right? How many of you love sugar? Now, if you have water, right, you add sugar into it. But I am saying that you have 5 gram of sugar, right? 5 gram of sugar. But water, I'm like, let's take it in grams only so that the conversion is easily possible. Let's say you have 100 grams of water. Random ways I'm picking up. I'm picking just random digits here, right? Don't take literal that, ma'am, how 100 gram in 5 gram. Like, just think about what is solvent and what is solute. Just tell me what is solute, what is solvent, right? Sugar is solvent, or water is solvent. Which one is the solvent? The one which is in the less quantity. You can't always think that sugar will be the solvent, salt will be the sugar will be the solute, salt will be the solute. The one which is in less quantity. That means this is the solute, this is the solvent. Now, if I exchange this, let's say we have 100 gram of sugar and we have 50 gram, or you can say, chalo, let's take it as 5 gram of water. Very less water you have, very high sugar you have. Now, which one is the solvent? This you will rarely see, but this is also possible, right? Now, in this case, which one is the solute? The one which is in less quantity. That means water is the solute. So, never remember that solid is solute, gas is solute, liquid is solvent. No, always remember the one which is in less quantity is solute. The one which is in more quantity is the solvent, right? Now, talking about the types of solutions, right? Now, first is binary solution. Binary, bi. What do you mean by bi? Bi, di, bi. This means 2, right? So, binary solution means when you have, see, solvent is always going to be 1. Maximum thing is always going to be 1, right? There will be always one thing, right? That is maximum in quantity, right? So, always you will have one solvent in a solution, but you will have different, maybe you will have one solute, maybe you will have 2 solutes, maybe you will have 3 solutes, right? This we do daily in our like kitchens, we do it daily, right? If you talk about, ma'am, what is binary solution? If you have solvent and one solute, that means you have water and you have sugar, you are mixing it, that is a binary solution. You are not mixing anything else here, that is a binary solution, right? So here what you have, just one solvent and one solute, that is called binary solution. Now, what if you have 2 solvent, one solvent, one solvent, and you have two solutes. Let's say you are having to the water, you're adding 1 tablespoon of salt, 1 tablespoon of sugar. Now you have two solutes and you have one solvent. That is called ternary solution. What is that called? Ternary solution. By T you can remember ternary means 3. Okay, that is 3 things you have in total, one solvent, two solutes. Now let's talk about quaternary solutions. That is very, I to drink it daily, right? Lemon water, right? Why? It's very needed. So much heat is over there on the planet, right? So what you add here, let's say you have water, right? Now you are adding water, then you will add lemon, then you will add sugar, then you will add some salt. You will mix it all together, right? Now you have so many solutes. What you have? You have 3 solute. You have, let's say, 1, 2, 1, 2, 3 you have solutes, 3 solutes, and there is only one solvent. That total it is making 4. 3 solutes, 1 solvent, total it is 4. That is why it is called quaternary. Quaternary basically means 4. So it is a quaternary solution. Okay. And when we are discussing about solution chapter, we will only discuss about binary, right? Because the quaternary will become very complex for you. So we are going to discuss about mostly, right? We are going to discuss about binary solutions where you will have one solute, you will have one solvent, and we are going to study different type of solutes, different types of solvents, right? Now, this thing you have also seen, right, so many times, but you know what? In JEE 2025, they have literally asked a question out of this. So this usually students ignore this, that who is going to ask this? This is also there in class 9th. Who is going to ask this? But they can ask you this directly in the exam, right? Very easy question they will ask you out of this, right? So you should also have a knowledge that, for example, gaseous solutions. The name gaseous solution means the solvent is gas. Liquid solution means solvent is liquid. Solid solution means solvent is solid, right? So solvent we have fixed. Okay, that means whenever I am talking about gaseous solutions, I have fixed that gas will be the solvent, right? So when you have gas as the solvent, that is in more quantity, right? But solute is changing. If you have gas as solute and gas as solvent, that is called, that is common examples are mixture of oxygen and nitrogen gas. But if you talk about solute is liquid, that means little amount of liquid you add into a gas, right? That is forming a, like for example, chloroform mixed with a nitrogen gas, right? Chloroform, like that is liquid, that is mixed with a nitrogen gas, that is forming a solution where solute is liquid and solvent is gas. Now, example of when you have solute as solid, right, and solvent as gas. So this is the solid, this is the solid, and this is the gas that you have. Camphor in the nitrogen gas, solid in the gas. Gas is in more amount, solute is in very less amount. That means camphor is in very less amount, right? So it is basically, we are talking about kapoor that you must have seen in your houses as well. Kapoor is a very, this is a very good diffuser, right? So how many of you have seen kapoor, camphor in like daily life? It's very good in killing the germs like in the air, right? And usually in sometimes in home also, in temples also, you will have like a smell of the, not smell, fragrance of camphor, right? It's tell me what is the process here? What is the process here that you have studied in lower classes? Process is sublimation. It is directly converted from solid to gaseous form, right? Isn't it? Yes. Monthly option. Oh, okay. Okay, that is clear. Now, if you have liquid solutions, now tell me liquid solution. Imagine, this will be very easy for you to imagine. Imagine water as the liquid. Now tell me this, you can easily tell. When you have gas in the liquid, any idea gas in the liquid, what do you have? You are like totally in love with that. Whenever you go to McD, KFC, anything you eat, you are like, oh, pass me that. What do you say? Coca-Cola, Pepsi, whatever you drink, right? All of these are what? You have carbonated drinks, these are, right? Carbon dioxide gas is dissolved in the liquid, right? So these are the carbonated drinks, right? So that you can say oxygen dissolved in water. So now oxygen dissolved in water. Okay, tell me one thing, how aquatic life is surviving. Aquatic life also, we are also living means we need oxygen. Aquatic life is also needs oxygen, right? So aquatic life is surviving because water that is in the ocean, right? You have ocean, aquatic life is in that, right? Now this aquatic life is taking oxygen from oxygen dissolved in that ocean water. And that's why the example is oxygen dissolved in the water, right? And that oxygen is usually given by the plants in the ocean, right? Because they inhale carbon dioxide, they give it oxygen, so they will give oxygen. Then animals, right? Not animals, basically the aquatic species, they are going to take out that, inhale that oxygen, right? Now, next is solid solutions. When you have solid as the solvent, right? So now you have solid as the solvent. Can you imagine anything here? Right? So we have not discussed in detail. So this is very simple here. Liquid in liquid, anything you add, right? So this ethanol dissolved in water. Tell me this. Ethanol dissolved in NCRT is literally like playing with your emotions. Okay, tell me what is this ethanol dissolved in water? Drink, right? Drink, which kind of drink, ma'am? We don't know any kind of drink, ma'am. Ethanol dissolved in water is alcohol, right? It is, they are talking about ethanol is alcohol, right? So they are talking about alcohol here, right? Ethanol dissolved in water, right? NCRT is also playing with your emotions right now. So solid in liquid, right? Solid in liquid, sugar dissolved in water, salt dissolved in water, anything, glucose dissolved in water, that is your solid in liquid, right? Now let's talk about solid solutions. Okay, let's talk about why you, for that you need to grow up firstly, है ना? Ma'am, no, ma'am, we are above 18, ma'am, we can drink, but it's not good for health, no, right? So I would not advise you to do that, right? It's not at all good for health. So let's skip that. So when you will become a doctor, I am saying, when you will become an engineer, then you'll go to so many parties, then you, at the end you will be like, oh my God, what is this, right? So that basically ruins your body only, right? No benefit it is giving to your body, right? So here, next is solid solutions. Now solid solution means solvent is solid, right? But we are changing the solute. Okay, so one example is gas in solid. Which kind of gas is a very important example? Solution of hydrogen in palladium. Now, this basically is used in catalysis, right? When you're doing hydrogenation, right? So how palladium is used as a catalyst? By adding solution of hydrogen gas into the solid, right? This is a very important thing for organic chemistry, right? Then you talk about liquid in solid, right? Liquid, amalgam of mercury with sodium. Now, if you see, mercury is liquid or solid at room temperature. Tell me, beta. Mercury is, right, solid. Mercury is solid, liquid or gas at room temperature. What is that, right? Yes. Yes, yes. Very good, very good. What is that? What is that? Mercury is a very beautiful liquid at room temperature, right? So this liquid is when you add it in sodium, right, you have amalgam, right? There is amalgam. Can you tell me what is amalgam, right? Basics of chemistry, right? In between, whatever knowledge of chemistry you will use in other sections of chemistry as well, that also I'm teaching you. Amalgam is a simple thing. When you fuse anything with sodium, that becomes amalgam. There is the zinc amalgam, right? So here we are mixing mercury with sodium, that is mercury amalgam, right? Okay, not basically amalgam is when you mix anything with mercury. Opposite, I told you, when you mix anything with mercury, right? That is amalgam. So like you have sodium amalgam, zinc amalgam. This is called the amalgam, right? So mercury is the liquid which is in very small quantities, and solid, sodium, zinc, all these are in high quantities. Okay. Now, next is solid in solid. Solid in solid, beta, all the alloys that we have, right? These are examples of solids in solid solutions, right? You mix solids, right? You melt it, then you form a solid out, new solid out of it, like you have steel, everything. That is your solid in solid solution, like your copper dissolved in gold, like all these are your solutions of solid in solid, right? Now, is this thing clear to everybody? Right now, I have just taught you the basic solute, solvent. How can they have different solute and different solvents? Now, next thing is to discuss about solubility. Ready, everybody? Right? Everybody? Siddharth, don't spam. Please don't spam in the chat box, right? Let students study and you also study, right? Don't distract everybody, and also you also don't get distracted, right? Very few seats you have, right? You have your whole career in front of you, right? Let's focus here, right? Now, let's talk about solubility. Solubility is, tell me one thing. If your mama is like, okay, bring one sugar solution for me, right? So what you will do, you will mix sugar into the water, right? You will be like, you will take sugar and you will just throw it in the water and you will take it and give it to your mom. She will scold you or she will praise you? Tell me one thing. First time, so she'll be like, very good, you have bought this for me, thank you so much, thank you so much. Then after that, after 1 minute, she'll be like, but sugar is not dissolved. You have to dissolve. You have to use your hand to dissolve it, right? You'll be like, oh, that I have to do. Yes, Diksha told me to dissolve it, right? So you have to dissolve things, right? So that means you have to mix things. You have to mix sugar into the water, right? But let's say you are like, okay, 1 spoon I'll mix, 2 spoon I'll mix, 3 spoon I'll mix, 4 spoon. Your mom will like, this guy want me to have diabetes or what, right? So 4 spoon you're adding. After 4 spoon, you're not able to add sugar into that water, right? So we are going to discuss the chemistry terms about it. This whole thing that you do every day, this is solubility. Solubility is that how much amount of solute is completely uniformly distributed among that solvent, that is called a solution you have formed here, right? So solubility definition is when you mix a solute into the solvent, right, that forms a solution, and how much dissolution is there, that is called solubility, right? Now, first thing is solubility of solid in the liquid. This is what I was talking about. When you have sugar, you are mixing it in water, you are mixing. You're like, okay, now I don't have any crystals of sugar. That means every particle of sugar is now mixed into the water, right? What I am telling you, you are like, okay, ma'am, I have a beaker. I am adding water into this, water. Now your mom be like, give me sugar, add sugar into it and give me, right? You are like, okay, you have added sugar crystals, but you have not dissolved it, right? You have not even heated it, right? Now your mom will like, what is this? I should not give you any work only. I'll do it myself only. This is what mom say. My mom though is like that only, right? I think moms all over universe are same only, right? Now you're like, oh my god, I have to mix it. You're mixing it because that lady is serving you food every day, right? You can at least mix the sugar into the water, right? So now you have mixed the sugar particles. Now your mom be like, okay, now it's sweet, now it's perfect taste, right? This, what you have done is dissolution. That is called the solubility, right? How much amount of it is fixed. But the amount is fixed. The amount is fixed. Amount is fixed means what you will observe while mixing sugar into the water, that maybe when your water is very cold, very few amount of sugar crystals will be dissolved, right? Sometimes you will be able to dissolve 1 spoon. It depends on the quantity of the water as well. If you increase the quantity of the water, we know that the amount of sugar that we are dissolving will increase or decrease. Tell me one thing. If you increase the quantity of the sugar, the quantity of the water, let's say, firstly, what you see that in 1 glass, right, only 2 spoons I'm able to mix, right? In 2 glass, right, tell me the the amount of sugar that you will dissolve will increase or decrease. It will increase or decrease. Tell me, everybody. It will increase or decrease. Yes, everybody. Yes, it will increase, right? Because the amount of solvent has increased, right? That's why the amount of solute dissolution will also increase, right? So what they did, they fixed it. They fixed it. They were like, this is very complicated. So you have to fix, you have to define solubility, you have to fix in how much amount of solvent we are looking for the solute. So they fixed it that in 100 grams of solvent, how much amount of solute dissolved is called solubility, right? That you take 100 gram of that solvent, you see that in that 100 gram how much amount is being added of solute, that is going to define its solubility. But here we are talking about at constant temperature and pressure, at constant temperature and pressure. Okay, understood everybody, that what is the definition of solubility, right? It's very easy to understand it when you are thinking about just that, okay ma'am, this much we are adding, this much we are adding, but the proper definition is in 100 gram of solvent how much solute is being added here, right? Okay, so let's see this. First is, yes guys, please stop spamming. Let's not ruin the lecture, right? By being a spammer here, right? Let's not do that, right? Because others have like future, right? They have like dreams. Let them, accomplish their dreams, right? So first thing is like dissolves like. That means polar will dissolve polar, non-polar will dissolve non-polar. It is observed that polar solutes dissolve polar solvents and non-polar solutes dissolve non-polar solvents. This concept will be more useful in organic and inorganic chemistry, right? But you just remember this thing that like will dissolve like, polar will dissolve polar, non-polar will dissolve non-polar more easily, right? We will see this concept in detail in organic, we will see somewhere, and in inorganic also this will be useful, right? Now, after this, let's see the concept of solubility, the exact process of dissolution and crystallization, right? Students, for this, I am drawing this one page for you, right? Okay. So here what I am doing is, you have a beaker, okay? You have a beaker, right? Now what you are doing, you have added water. This is a very important thing. This is exactly the line of your NCRT, right? Now what you are doing here, you dissolve some sugar crystals into it, right? You dissolved one sugar crystal, you dissolve second sugar crystal, third sugar crystal, fourth sugar crystal, fifth. Why I'm adding it like this, I'll tell you. Now, let's say it has reached a point where no more sugar crystals can be dissolved, right? No more sugar crystal, I'm saying, can be dissolved at one point. When no more sugar crystals can be dissolved, that is called its saturation point. That is called its saturation point. When you're like, I can't study more, ma'am, that is enough, I'm done for today. That is your saturation point. And when sugar crystal, when the solvent is like, I can't dissolve more of solute, that is its saturation point. It is now a saturated solution. But in reality, is it really happening? Or is there any equilibria that is maintained? In reality, let us see how come a saturated solution is a saturated solution, why it is not able to dissolve more solute into it. In reality, what is happening? You have a beaker. Now, it has reached its saturation point. In reality, what is happening? I am adding more yellow is after saturation. After saturation, more sugar crystals I am dissolving. More sugar crystals I am dissolving, right? It's like, students, you are like, ma'am, I can't study more. I'll be like, you have to study, you have to study, you have to study. what you will do? Tell me what happens, right? This is you. This is you. Here you are like, ma'am, I can't study more. Ma'am, I can't study more. Ma'am, this is enough. Ma'am, for today, this is enough. But I am like, you have to study, you have to study, you have to study. Now, what will happen? This whole that you have actually learned before, when I'm adding more, I'm adding more, when I'm adding more, what will happen? What you have learned before, you will start forgetting that. Isn't it? This is what happens, isn't it? When I forcefully ask you to study more, you will tend to forget about the things that you have learned before in the day. Right? This is what happened. This is why saturation. Saturation means it's not like you're not able to absorb the incoming information, but you're also forgetting the before information that you had. Same thing happens with the solute and solvent dissolution. What happens, right? Earlier, it has dissolved these 5 particles. Now, what is happening here? This is already dissolved. This is already dissolved. This is dissolved. This is dissolved. This is dissolved. Right? All of these particles are being dissolved. Right? Now, what is happening? You are adding more sugar crystals into it. More you have added. More you have added. Now, what will happen? See this. It's not like this sugar crystal will not be dissolved. This sugar crystal will be dissolved. That is the process of dissolution. But at the same time, one already dissolved sugar crystal, right, that will crystallize. That will come back to its original form. So, 2 processes are happening here. One is dissolution, right? Other is crystallization. Tell me, beta, if this is clear to all of you or not. Is this thing clear to every one of you? The process of dissolution and crystallization have a dynamic equilibrium between them. As soon as you are dissolving the new added sugar crystal, the old already dissolved sugar crystal will get out of the solution and will be crystallized. That is called dissolution and crystallization. They are coming together with the same speed. That's why to you, actually what is happening, you are not able to absorb more amount of solute. But in reality, more solute is being dissolved, but the solute is forgetting the information that it had before. That means the already dissolved solute is now getting crystallized. That means it's like you, I give you, you are at your saturation point and I can't study more. I'm giving you more information, you will start forgetting the information that you had before, right? If this is clear to everybody, then let me know in the comment section. Give the spam the chat box with green hearts, right? If this thing is clear to all of you, right? Okay, if this thing is clear to all of you, then spam the chat box with green hearts, right? Okay, now let us see solubility of solid in liquid. Solid in a liquid. That means whenever I say solid in a liquid, you just talk about that, ma'am. Here we have sugar in water, right? Just think about sugar in water. Now, first thing is effect of temperature, other is the effect of pressure. Effect of temperature, just tell me one thing, because this is from your real life only. Tell me one thing. If you have you ever seen your mom or your father also? Now, fathers also cook, right? Okay. So, now, have you ever seen that what we do in the kitchen when we are not able to dissolve sugar, right? What we try to do? We try to heat it on the pan. We dissolve some sugar in water. We heat it on pan. The dissolution of the sugar is increased. That means when we increase the temperature, sugar dissolution, that means solubility increases. But ma'am, is this in all the cases or not? That is very important to note down. And that's why this is a very, very important point from the equilibrium chapter, right? We have studied that when you talk about endothermic solution, right? In endothermic, I'll just write here, endothermic solution, temperature is directly proportional to the equilibrium constant. But in exothermic solution, temperature is inversely proportional to equilibrium constant. This we have seen in equilibrium chapter in your class 11th, right? Who are not good in equilibrium chapter, don't worry. I'm going to take equilibrium chapter also in detail for class 11 students. You can watch equilibrium chapter again in that particular sessions, right? I'll inform you that on my Telegram group, don't worry, right? Now, here you have, this is from equilibrium chapter we have, right? This is endothermic, exothermic. That means if you remember this thing will be already sorted. Endothermic means when energy is required, right? So when energy is required, that is an endothermic reaction. When you increase the temperature, solubility increases. And when you dissolve sugar into water, that is an endothermic reaction, right? Okay. Now let's talk about an exothermic reaction. If they give you any exothermic reaction where heat is being released, right? In that case, right, when you dissolve something and suddenly heat is being released, right? In that case, when you increase the temperature, solubility will decrease, right? So when you have an exothermic reaction, solubility will decrease with the increase in temperature. With the increase in temperature. Is this thing clear to everybody? What you have to notice here? Just that this is the conclusion from equilibrium chapter. We have seen this with the formula. We have concluded this thing from chemical equilibrium, right? That endothermic is temperature is directly proportional to equilibrium constant. Here equilibrium constant is solubility. It is KSP that you have already studied in ionic equilibrium, right? So what you have to remember, that temperature is, or if you don't want to remember the equilibrium here, right, you can just remember one thing, that in exothermic, temperature is directly proportional to solubility. In exothermic, it is inversely proportional. In endothermic, it is directly proportional. That's it. But here I am talking about only solids and liquids. But if you talk about, ma'am, pressure, tell me one thing. Do solids compress? Solids, you have seen this in 9th class. Tell me, solids, do they compress? Do they compress? Right? If you try to compress some solid, I try to compress this, I won't be able to do it, right? So solids are incompressible. That is the reason pressure will have no effect on them. There will be no effect of pressure on the solution which is solid in liquid, right? Here I am talking about only solids and liquids. I'm not talking about gases and liquids. So now let's talk about gases and liquids. What about gases and liquids, ma'am? Now, in this case, you have a gas that is in the liquid, right? Now, see this very carefully. What we have, both will have an effect. Effect of temperature, right? How temperature is going to affect it. Tell me one thing. You bought Coca-Cola. Some guests are there in house, and you are like, oh, wait a minute. I'll just heat this. I'll just warm this Coca-Cola. Then you can drink it. Do you do this? Do you do this to your guest? Like serving them warm Coca-Cola? Do you do this? If you do this, you are a very bad host, right? So don't do this ever. Why? Because everyone hates. No one actually drinks warm Coca-Cola. We need, what we say, let me just cool down the Coca-Cola more. Let me just bring it out from the fridge, right? Why? Because gas is dissolved in the Coca-Cola, right? In the carbonated drinks, you have gas that is dissolved. You want it to dissolve more so that you can have that fizzy effect, right? That's why you drink it, right? What else? Why you drink it, right? Because you have that fizzy effect, right? That's why you drink it, right? So gas is more dissolved at lower temperature, right? So gas is more dissolved at lower temperature. Gas is dissolved at low temperature. It needs low temperature. So can I say, as temperature increases, solubility decreases? So in this case, definitely solubility and temperature are inversely proportional. When you increase the temperature of a carbonated drink, the gas will go. The gas will be like, tata, bye bye, I'm going, right? So that is inversely proportional. Let's see effect of pressure, right? What is the effect of pressure? Now tell me one thing, right? Why carbonated drinks are under so much high pressure, right? It's not like you give them less pressure and they will be easily dissolved in the liquid. If you want to dissolve any gas in the water, you have to keep it under high pressure. That's why you must have seen that when you open any carbonated drink, right? the gas will, you will see effervescence, right? So the gas will pop out, right? Now, if you keep it open, right, the gas will evaporate, the gas will go out in the surroundings. You will only be left with a drink which is having a lot of sugar, nothing else in that, right? So why we keep it under, like we close the bottle very properly? Why so? Because we want the gas to be under pressure, right? So just like society wants to be under so much pressure. So you are like carbon dioxide in the carbonated drinks. Everyone wants you to be under so much pressure, isn't it? So when you increase the solubility, pressure, that means you can also say when you increase the pressure, solubility will increase. Why so? Let's say these are the molecules, right? So when you put pressure, when you put more weight, pressure will increase, molecules will come together, right? They will be more close to each other. That's why they will have more pressure. That means that they will have more solubility also, right? Is this thing concept clear? Solubility of gases in liquid, solubility of solids in liquid, beta. Tell me everybody if that is clear to every one of you or not. Now this is a real life example of solubility. That is why do aquatic species prefer cold over warm water, right? You must have seen, I think in Kerala beaches also, what we are seeing that aquatic life, they are coming out of the ocean. Why they are coming out of the ocean? Can you tell me that? Why they are coming out of the ocean? What they want to see you? They want to also lie on the beach, right? They also want to chill, right? They are not happy with the ocean. Why they are coming out of the ocean, right? You must have, I think, mm, I don't remember the name of that fish, doomsday fish, I think, doomsday fish. Why in some areas, right, we can see that was not never out of the ocean. Now it is out of the ocean. We can see it in some places of the world. Why it is so? Because of global warming. The actual reason is global warming, right? We are increasing with so much pollution. What is happening on Earth, right? Every year the temperature, the average temperature of Earth is increasing. Even the glaciers are melting, right? So don't you think that the ocean water, the deep inside the ocean water, that is also warming up, right? So that is the reason they are coming out, because they hate warm water. They like cold water. Now tell me why they like cold water. Why they like cold water? Ma'am, they also like, ma'am, chill water. Ma'am, I also like water from my fridge. They also like, ma'am, cold water. Is it so? No, right? Why they like warm water, cold water? Because in cold water, see one thing. Cold water means, cold water, tell me, that means low temperature, low temperature. And we have learned that in low temperature, solubility will be more. So solubility, what they need, what these fishes need, they need oxygen. Solubility of oxygen will be more. That's why they want to stay there. They want to stay there because we are not able to maintain the balance of the oceans. That's why they are like, humans, you are ruining my life, and that's why they are coming out of the ocean. They never want to come out of the ocean. We are forcing them to come out of the ocean, right? So we are not doing good with the aquatic life, right? So I think this is an alarm that we should now stop, right? Isn't it? So many industries, so many things, we are ruining our world only. What we are doing here, right? So let's see some questions based on this. Solubility of substance is 40 at 25 degrees Celsius. This means the solution is unsaturated, saturated, supersaturated, none of these. So saturated solution, see, when they are giving you 40 at 25 degrees Celsius, that means you have fixed the solubility. You are saying that beyond 40 you can't add the solute. This means 40 at 25 means 40 gram is dissolved in, maximum only this you can dissolve, is dissolved in 100 gram of solvent, right? That means 40 gram of solute is dissolved in 100 gram of solvent. That means beyond this you cannot dissolve. So that means this is a saturated solution. You have calculated the solubility. No more solute you can dissolve into it. So it is a saturated solution. And I think doomsday fish was seen outside the ocean in Tamil Nadu. Really, Abu? I don't know about that news. If it is there, then definitely we are doing something, not good for this world. The world will also, this ocean, this life, this natural life is also fire back, right? It is doing that only, right? So, what to do, yeah? What to do, right? This we have seen throughout the world. This is happening, right? So, it's not like they are people are relating doomsfish with some curse. They're saying that it's not good, something big is going to happen. They're alarming us. The scientific reason is this. They are not able to survive in warm water. That's why they have to come out, because they want to survive. Right? That's the reason. So, next is the solubility of substance in water is 40, right? The maximum amount of solute required to prepare a saturated solution of 50 gram of water. So first thing is, see, solubility of substance is 40 means 40 gram in 100 gram of solvent of water, right? Now you want it for 50 gram. So if for 40 gram, for 100 gram you have 40 gram, that means for 50 gram you will have 20 gram, right? So answer will be 20 gram is the correct answer here. Is that clear? Answer means D, that is 20 gram is the correct answer. Fourth is the correct answer here. Right? Okay. Yes, students, solubility topic we have covered. Now let's discuss about vapor pressure, partial pressure. What exactly is this? Right? So, how many of you know what is the difference between vapor pressure and partial pressure? The simple thing is, let's discuss that. You have a liquid A, you have a liquid B. This is a pure liquid A, this is a pure liquid B, right? This pure liquid A is making some vapors, because the every liquid which is a volatile liquid that will form vapors. Volatile liquid means the one which is forming vapors, right? So this liquid A is a volatile liquid, this liquid B is a volatile liquid, right? So this is forming some vapors. The vapors will put some pressure on this liquid, right? The vapors will have some pressure on this liquid, that is called vapor pressure, right? When we talk about the pure liquid A, then the vapor pressure term we use and we denote it by P naught A. That means the vapor pressure of liquid A, right? When the liquid A is in the pure state, right? And same with B. This is also having vapors, right? It is putting pressure on the liquid, right? That is called P naught B. That is called P naught B. And this naught means that A and B both are individuals. They are not a couple right now, right? Both have, let's say this is A, it has its own problems, right? Single. This is also, B is also single, right? Has its own problems. The problems are P naught A and P naught B. They are irritating them, right? Now, they are a couple, right? Now, they are a couple. Now, what will happen? There will be some vapors of A, right? And there will be some vapors of B, right? Now, what you will see, that there will be vapor pressure of A and B both. That means what, ma'am? What do you mean by that? Simple thing is that here, vapor pressure of A is denoted by PA and B is denoted by PB. Why? Because right now they are a mixture, they are a couple. Now, the pressure that is by the vapors of A, that is called PA, that is the partial pressure. Partial means parts, right? Partial means now they are not in their pure state. Now they are in the mixture. In the mixture, how they are putting the pressure on the full mixture, right? That is called PA, that is called PB. The pressure by A vapors is called PA, the pressure by B vapors is called PB, right? And when you add these two together, these two things together, you will get PT, that is the total pressure. You will get PT, that is the total pressure. Is this thing clear to everybody? PA, you have PB. What is pure vapor pressure? Vapor pressure, we talk about the vapor pressure of A or B in the pure state when they are not mixed with anything. But when we talk about PAPB, these are the partial pressures. Okay, this and this are the partial vapor pressures, right? But this and this, they are called the vapor pressure, just the vapor pressure. Okay, this is denoted by naught, this is not denoted by naught. My God, I just got a current. Okay, that is clear to everybody or not? Pratyush, please don't spam, yaar. Please don't spam. If you really want me to see your comments now, then you can just, if there is something very important, no, just give it time, right? Give it time. Please don't spam, right? Because I know you are someone who actually studies, so I don't want you to block here, right? That's why I'm saying you have a very important thing to tell. Then beta, you can always write it down in the comment section. You can always write it on our Telegram channel as well. I actually genuinely see your comments, right? So you don't have to spam here, right? I don't want you to be in the block list, right? So please, because I know you are genuine person who actually wants to study. Otherwise, right, all the spammers out there, right, don't ruin the class. This is the first class, right? That's why I'm not doing anything, right? But otherwise, it's very easy to, put the spammers on block, right? Don't do that, right? Extremely sorry, no worries, yaar. Video book list, video in which topics we should ignore and study from Solomon's. Pratyush, same comment, same thing, copy paste in the comment section. Right now, I can't give you the answer in between, right? Write it down in the comment section. Okay, right now, just focus on the class. Now, students, tell me if this thing is clear to everybody. What is pure vapor pressure? What is partial vapor pressure? Right? Is that thing clear to everybody? Pure vapor pressure, partial vapor pressure, right? Because they will not give you in the questions, right? They will not give you this is pure, this is partial. You will have to learn it yourself, right? Now, this thing we have already learned, right? Now, I have already told you about mole fraction also, right? This is in the concentration terms. What is mole fractions? Mole fraction of any component is the number of mole of that component divided by the total number of moles. And mole fraction of all the components in the solution is equal to unity. This you have to remember, because next two laws that we are going to do, Henry's law and Roults law, you need to have these general knowledge about what is vapor pressure, pure vapor pressure, mole fraction, right? Only then you will be able to understand that. Now, wait a minute. This I'll do not here, right? We will do this plot when we study Roults law. Okay, yes. Wait a minute, right? Okay, chal. Now let's do this here. Now let's see what is Henry's law. Okay, students, let's see what is Henry's law. Now, students, we have studied that when you increase the pressure, solubility increases or decreases. When you increase the pressure, solubility will increase or decrease. Solubility is going to increase, right? Same thing Henry said. Henry said that the solubility of a gas in liquid, right, that is directly proportional to the partial pressure of the gas. That means solubility is directly proportional to partial pressure of the gas present above the surface of the liquid or the solution, right? That is dependent on the partial pressure of the gas, right? This is what Henry told. Now, after this, everyone was like, how to measure now solubility? So Henry, what he said that you can measure solubility with mole fraction. This is nothing but mole fraction, right? Mole fraction is the measure of solubility, right? That means instead of writing mole solubility, you will write mole fraction here. So what you can write here, solubility is directly proportional to pressure. That means pressure is directly proportional to solubility. But solubility, we know that is defined as mole fraction only, right? That means we will erase this proportionality sign and you will have a constant that is kh, and this is kh, that is the Henry's constant. This is called Henry's constant. Okay, this is called Henry's constant. Understood? This is called Henry's constant. Now, this is called mole fraction. This is called mole fraction, right? This is called Henry's constant. This is the pressure. This is called, whole formula is called Henry's law, right? Okay, KH is Henry's constant, which depends on the nature of the gas, right? This is mole fraction that defines number of moles by total moles, and P is the pressure of that gas, right? Understood, everybody? Right? Now, this is our Henry's law, and how in this law we can define it. The partial pressure of the gas, that is P, is proportional to mole fraction of the gas in the solution, right? We are talking about mole fraction. Students, this is the liquid. See, there are two kind of mole fraction. Understand this thing. This is very important because based on this, in JEE Mains and JEE Advanced, they can trick the questions, okay? So this is your, this is, let's say, this is your liquid, right? And you have vapors that are inside. No, not the vapors. Wait a minute. Mole fraction of the gas in the solution, right? Let's say you have this gas here, right? Now, he is saying that this gas, some amount of gas will be in the solution, some amount of gas will be outside the solution, right? He is talking about this amount of gas that is inside the solution, this amount of gas that is not inside the solution, that mole fraction is defined by Y, right? This formula also we will study, but you should understand that whenever in the question they give you mole fraction in the vapor phase, they are talking about Y. Whenever they give you mole fraction in the liquid phase, then only they are talking about this mole fraction here, right? Okay. And in Henry's law, we are talking about mole fraction in the liquid phase, not in the, yes, we will discuss that, right? Now, next is three applications of Henry's law that we have. First is hypersomnia or anoxia, right? This is at high altitudes, right? What you will see that the pressure will be low. Because the pressure is low, that's why solubility is low, right? That's why it is very difficult for the people who, like, who climb high mountains to inhale, right? That's why we have also seen so many death reports, right? Why? Because when you are like in very high Himalayas, right, what happens? Pressure is very low, solubility is low, and we need oxygen to survive. So that's why when we don't get oxygen, we die, right? So that condition, the suffocating condition, is called hyponaxia or anoxia, right? Next is scuba diving, right? In scuba diving, what happens, right? In scuba diving, what happens? Scuba divers, they can't inhale. Like, how can they inhale, right? Deep down in the sea, right? What they do, they carry out one cylinder, right? In that cylinder, we have oxygen, we have nitrogen that is mixed, right? So that they can survive in the sea, right? But now we know that when you go inside the sea, pressure will increase, right? When you go in, like in the atmosphere, pressure decreases. When you go in the ocean, pressure increases. That's why solubility will increase. You'll be like, ma'am, that's a good thing. Ma'am, if we are getting more oxygen, that's a good thing. That's a good thing until you are like feeling happy. I'm inhaling oxygen. Good. But when you come out of the ocean, what happens? The solubility decreases, right? Coming out, what will happen? Pressure decreases, solubility decreases. And this leads to a condition that is called bends, right? This leads to a condition that is called bends. That is not like, that is a very bad condition for the nerves as well, right? It's a very suffocating, disgusting condition for the scuba divers, right? So to avoid this, helium is added in the cylinder of the scuba divers, so that they can also inhale helium. Helium is an inert gas. It is not reactive with our body, with our veins, right? That's why it will not get dissolved in the bloodstream, and that's the reason we add helium, so that there is less effect on the scuba divers, right? Okay, yes, everybody understood. Next is carbonated drinks. Again, we know that why they are at high pressure, because as pressure increases, solubility increases. That's why they are kept at under very high pressure. Okay, understood everybody? Understood everybody? Yes. Now let's talk about mole fraction in vapor phase, right? Liquid phase, I told you liquid phase is this mole fraction. In vapor phase, the mole fraction is called Y. It is represented by Y. And you know what is the formula of this? It is partial pressure of that gas equals to mole fraction in liquid phase, mole fraction in liquid phase, right, multiplied by the total pressure, right? So you will have total pressure. This is the mole fraction in liquid phase. Total pressure means the mixture, the total pressure of the full mixture, right? This is the partial pressure of that gas, right? So partial pressure of the component, Y is mole fraction of in the vapor phase, and P total is the total pressure of the mixture here, right? Okay. Now let's see this JEE main questions here. Question here. Which one of the following statement regarding Henry law is not correct? Let us see that here. I hope so. This is not your, yes, this is not your question of homework, right? So JEE mains 2019 question it is. Which one of the following statement regarding Henry's law is incorrect? First is, higher the value of KH at a given temperature, higher is the solubility of gases in the liquids, right? Different gases have different KH values at the same temperature. The partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. Partial pressure of the gas in the vapor phase is directly proportional to the mole fraction. The value of KH increases with increase in temperature, and KH is the function of nature of gas. Yes, everybody. Let us see. Let us see. Okay, great. So this thing is definitely correct that different gases have different KH values. Then there is partial pressure of the gas in vapor phase is proportional to mole fraction. This also we have seen that partial pressure is proportional to mole fraction. Then the D is the value of KH increases with increase in temperature, and A is higher the value of KH at a given pressure, higher is the solubility of the gases, right? So solubility we can't define, but definitely the value of KH increases with increase in temperature, and KH is a function of nature of the gas. So we can say that A is the incorrect option here, right? Okay, A is the incorrect option here, right? Okay, next is we have question that is Henry's constant for 4 gases alpha, beta, gamma and delta is given to you in water. These different things are given to us, different KH values are given to us. This is also your JEE mains 2020 question, right? Previous year question of JEE mains, right? Now, can you explain the mole fraction again? Mole fraction is simple. Mole fraction of liquid phase is given by this thing, right? That is number of moles of that thing divided by total number of moles. But mole fraction in the vapor phase, that is given by pressure equals to partial pressure is equals to mole fraction multiplied by the total pressure, right? Okay, understood? And what is this, ma'am? What is this difference here? Then the difference is that when the mole fraction, we are talking about the component of gas that is in the vapor phase, that is mole fraction of vapor phase, and the component that is mixed in the liquid, that is called mole fraction in the solution. Okay, understood? Now let us talk about this question here, that is Henry's constant for 4 gases are given to us, density is given to us. This table implies which thing? Solubility of gamma at this temperature is lower than at this temperature. Okay, pressure of 55.5 molar solution of gamma is 250 bar. Alpha has highest solubility. They are asking you, the table implies that which thing? The pressure of this molar solution is 1 bar. Okay, This all you have to tell him. Everybody, let's see this, right? So first you have to solve everything. First is first question, let us see, solubility of gamma at this is lower than this. We know that on increasing temperature, solubility of gas decreases, right? So here, if you're talking about one gas, that is gamma, this gas we are talking about, we are decreasing the temperature. So solubility will decrease or increase. Solubility will also decrease, right? But here they are saying solubility of higher temperature is lower. Right? Higher temperature solubility will be more. Right? So that means this is a false statement. Right? We can say this is a false statement because when you are lowering down the temperature, solubility should decrease. They are saying that this solubility should be more and this solubility should be less. But they are saying the opposite thing, so that is a wrong statement, right? Second statement is pressure of 55.5 molar solution of gamma. Gamma is given to us, KH value is given to us. See, simple thing is pressure is equals to mole fraction into KH. KH is given to us. If you're able to understand how can you calculate the value of mole fraction from molality, you can easily answer this question, right? Now this I have taught you in the concentration terms, right? That how to get the value of mole fraction when you have molality, right? So molality, students, is given to be 55.5 molar. Can you tell me what is molality? Means number of moles of solute is 55.5, right? 55.5 in how much gram? Can you tell me in how much gram? 1000 gram of water, right? 1000 gram of water it is there, right? So we can easily say 55 of molar, that means number of moles of solute will be 55.5, right? And why it is 1000 by 100? Can you tell me? Because water has molar mass 18, water has weight 1000 that we have seen here. If you're not able to understand this part of the lecture, ma'am, how can you write this thing over here? Then watch concentration terms, right? This will be more clear to you, right? Now, what is mole fraction? It is number of moles of solute that we have calculated 55.5 divided by total moles. This added this because number of moles will be given weight divided by molar weight. So that is going to be the answer. And KH value for gamma is given to you, that is 2 into 10 raised to power minus 5. This is given to you. Just put this value and you will get your answer here as 10 raised to power minus 2 bar. And this is given to be 250. So that is also the incorrect statement here. Right? Wait a minute. Wait a minute. Are they asking the table implies which of the following? 250 bar? 10 raised to power minus 2 bar, na? Wait a minute. Alpha has higher solubility at a given pressure. The pressure of this is 1 bar, right? Here they are talking about delta, they are talking about, na? Delta they are talking about. So we have to put the value of delta here. That is given to be 0.5, right? So wait a minute, I'll just put it here. So that means this should be for delta they are asking. They are not telling about, this is about delta, right? So that means the solution is wrong here. Okay, so I'll just correct it here, right? So it is going to be what, students? It is going to be, let's write it here. It is going to be, this is going to be, KH is 0.5, right? You solve this, you have to get the value. If they're saying this statement is correct, that means the value will be 250 kilobar after 250 bar after solving. Only then this statement will become correct. Okay, let's see why this statement is coming out to be correct. Solubility, when you increase the temperature, solubility increases, right? Solubility of gamma at this is lower than this. At this is lower than this. This should not happen, right? I think there is some statement is wrong, because solubility of gamma, if you see, at more temperature, if you talk about more temperature, solubility will be more, right? So it is lower, that is not correct. It is more than that. No? It will be more. If you're only discussing about one gamma, where we have fixed the KH value here, right? So I think for that, right, the statements we need to see it here, right? Because in increasing temperature, solubility of gas. Wait a minute. I'm so sorry. I was thinking about pressure the whole time. I'm so sorry. I'm so sorry. I'm thinking about pressure the whole time. I'm so sorry. Right, my bad. Yes, my bad, my bad. Okay. Uh, so sorry. Right, pressure is inversely proportional to acha. We are talking about temperature. Temperature is inversely proportional to solubility, because when you increase the temperature, the molecules will distribute here and there. That means the solubility decreases. Yes. So that means solubility of gamma at higher temperature will be low, which is the correct statement. So 1 and 2 are going to be the correct statement. I'm so sorry about it. I have also not seen your comments here. Right? Okay. So sorry. Right? Chalo. A and B both are the correct statements. Right? Yes. And that's it. Okay, A and B are the correct statement. Now let's talk about the last part of today's lecture, that is Roults law. Now tell me Roults law. Most of this we have already discussed, right? We have discussed about vapor pressure. We have discussed about partial vapor pressure. And if you remember, in that I told you PT. That is going to be PA plus PB. Right? You have two things here. You have two things here, two mixtures A and B. A and B are the pure things. Okay, I'll just bring out that page over here, so that more understanding you get about this. Right? So that more understanding you get about this. Right? So if you see this here, you mix two pure liquids, you mix it, you get a mixture, and the total pressure that is generated by the vapors of A and B is called PA plus PB, right? But in this case, PA is different, PB is different from P naught and P naught. It's like when you see, simple thing is, just imagine that this is you when you're studying like not in group, you are studying alone, right? You are sitting solving examples, right? Your efficiency will be different, right? This is your friend B who is studying alone. Let's say this is Chintu, this is Mintu, right? Chintu is like sitting alone, like studying. Mintu is sitting alone and studying. Now when they are placed in the same, like in the same room, and you ask them to study, right, what will happen, right? Their efficiency will change, right? Okay, so that is called PA and PB, right? Here they are making different vapors. When you mix them, they will make different vapors. The total vapors is called PT, and this by A is called PA, by B is called PB, right? Now we will understand the derivation here. We know that PT is equals to PA. What is PA? Raoult's law says that the partial pressure is equals to mole fraction multiplied by the vapor pressure, right? That means the partial pressure, right? If you talk about the partial pressure of A in the mixture is equal to mole fraction of A multiplied by the vapor pressure of A in the pure state. And of B is also mole fraction of B, and this is mole fraction of B multiplied by the vapor pressure of B in the pure state, right? Now we have also learned that mole fraction of A and mole fraction of B are 1. Okay, so when we say that it is 1, you can replace anything here. Okay, so I'll replace B here. Mole fraction of B is equals to 1 minus mole fraction of A. You just put it here. Mole fraction of A, P naught A, plus mole fraction of B, you can put it here. This will be 1 minus mole fraction of A. We have to keep this in 1 just. This is also the formula of Raoult's law. This is also the formula, right? So we have to now redistribute it. So it will be P naught B minus mole fraction of A, P naught B, right? So what can you do here? P naught of B plus plus P naught of B plus, take the mole fraction of A common, this will be P naught of A minus P naught of B. That means this also you can write as your, so you will see this also is your equation. General equation is this only. From this you can generate it in the form of mole fraction of A as well. Same process you can generate it in the form of mole fraction of B as well. Now the definition is for a solution of volatile liquids. Can you tell me volatile liquid means both are making vapors? See, if both are making vapors, only in that case you will get to know what is vapor pressure of A, what is vapor pressure of B. If one of them is non-volatile, then the vapor will not be there, right? So, volatile liquids, the partial vapor pressure of each component, partial vapor pressure is directly proportional to its mole fraction present in the solution, right? And we will replace that proportionality sign with the vapor pressure in the pure component, right? Is that clear to everybody? Right? Okay, students? Okay. Yes, everybody. Yes, that was, I think, a J, maybe that is a J advanced, right? Okay. So let us see the next part here. This we have done. No, this we have not done. Right now, when you see this, when you try to draw the graph, this is, we will also study in ideal solution in the next lecture, right? So this is basically how you graphically draw Roults law, right? So here you will keep mole fraction of one component as 0. Here you will keep mole fraction of other component at 0, right? And here what you will see, this P1, this is P01, this is P02, that is telling you the pressure, that is telling you the vapor pressures, right? And this is when you join this, basically what is happening, you make different things here. This is 1. Okay, I'll just this for you, right? This is 1. This is when you have mole fraction of 1 as 1, you have mole fraction of 2 is 0, right? So what is happening here? Mole fraction of 2, we are increasing. What we are doing? We are increasing mole fraction of 2. As mole fraction, we know that partial pressure is directly proportional to mole fraction. As mole fraction increases, partial pressure will also increase. This side you have vapor pressure or partial pressure, right? So as the mole fraction increases, partial pressure increases, right? Now we are going to draw the same graph opposite here, where mole fraction of 1 is 0, mole fraction of 2 is 1. In this case, this mole fraction of 2 is decreasing. When mole fraction of 2 is decreasing, what you will see here, what you will study here, when mole fraction of 2 is decreasing, mole fraction of 1 is increasing, right? When mole fraction of 2 is decreasing, 1 is increasing. As mole fraction of 1 increases, the partial pressure of 1 also increases. That's why this is the partial pressure of 1. This is the partial pressure of 2. Right? This is the partial pressure of 2. And when you join these two things, that will define you PT, that is P1 plus P2. Right? That's how we draw this graph. This is the graph, right, of Roults law, that how they behave, how solutions behave in the Roults, according to the Roults law. Right? The plot of vapor pressure and mole fraction of ideal solution at constant temperature. Is this thing clear to everybody or not? Right? Is this thing clear to everybody or not? Right? Okay, students. Now, let us see some questions based on this. Right? Let us see some questions based on this. One is JEE Main 2024 question, that is a solution of two miscible liquids showing negative deviation. Acha, this is, so we will do in ideal, non-ideal solution. This is, we will not do it today, right? That we will not do today, right? So let us see what homework we have, because Roults law is the continuation. Okay, that is a continuation, right? Shall we do the questions before? So let's do. Firstly, you can take the screenshot here, students. Take the screenshot of this question here, right? I'll solve this tomorrow for you. Take the screenshot. The Henry law constant states that solubility of gas in this, mole fraction of gas, partial pressure of gas, all of this. And I want you guys to comment it down. This is your first homework question. You can write down one is A, B, C or D, right? Then the second question is this one, right? Write it down in the comment section whether the answer is A, B, C or D, and I'll see how many of you are dedicated enough, right, to tell me in the comment section, right? Okay, yes, your mom is calling, my stomach is calling to eat dinner. Don't worry, just last question we have, right? But before that, who have taken the screenshot? Everybody who have taken the screenshot, I want to see the answers in the comment section. Take the screenshot even if you are watching the recorded version. Take the screenshot, right? And answer it in the comment. Take the screenshot and answer it in the comment section, right? I want to see your comments in the comment section. Now, let us see this JEE advanced question from 2009, right? Now, this question, right, let us see what they are saying here. The Henry's law constant for the solubility of N2 gas in water is this. That means they have given you the value of KH as 1 into 10 raised per 5, right? The mole fraction of N2 in air is this. Mole fraction of N2 in air. Who will tell me this? Who will tell me this? Mole fraction, are they giving us the value of this or they are giving you the value of this? Mole fraction of N2 in air. What they are giving? Mole fraction of N2 in air. You can, some students say mole fraction is given 0.8, ma'am, answer will be 1 into 10 raised per 5 multiplied by 0.8, ma'am. This is so simple. How they have asked this in JEE? How they are asking this in IIT, right? So, the problem is that this is the tricky part. The mole fraction of N2 in air is 0.8. That's why when I was teaching you in air, in liquid, you have to understand that, right? Mole fraction, what this mole fraction is giving, what this mole fraction they are giving. The number of moles of N2 from air dissolved in 10 moles of water at this temperature and this pressure is, right? They're asking the number of moles. So let's see this, right? First thing is, we know one thing, that what they have given you, pressure of N2, right? They have given, see, one thing is, let's not do this thing here, right? I think you should know the full formula. Acha, tell me firstly this thing, what is given to you, right? Because in detail it is not written, so I'll have to write it in detail. Tell me one thing, what this is X or this is Y, which thing is given to you? Y, right? Y is given to you, right? Y is given, beta. Y is given. That means mole fraction in vapor phase is given to you. If you know the formula, I have told you the formula in today's lecture. Mole fraction in vapor phase. This is total pressure, right, multiplied by mole fraction in vapor phase will be your partial pressure. Have we done this formula? Have we done this formula, students? Everybody? So can I say that from here I can calculate the partial pressure? From here I can calculate the partial pressure. Partial pressure is, this is 0.8. This is multiplied by total pressure, that is given to be 5. Right? Now, they are asking you number of moles of this. See, for this we know one thing, right? We have calculated the partial pressure. From Henry's law, we know that partial pressure is equals to KH into mole fraction, right? That means mole fraction will be partial pressure by KH. So can I write it here? Mole fraction will be partial pressure by KH. So can I write partial pressure as 0.8 into 5 divided by KH is given to be what? KH is given to me 1 into 10 raised per 5. 1 into 10 raised per 5. So can I calculate the mole fraction here? This is the mole fraction. This is where you calculated the mole fraction. Now they are asking you number of moles of N2 from air dissolved in 10 moles of water. That means if you say mole fraction of N2, it is number of moles of N2 divided by total moles. Number of moles of N2 we have no idea. Number of moles of N2 you have to calculate. Number of moles of N2 plus number of moles of water. Now tell me mole fraction, you know, you have calculated from here, that is 0.8 into 5 divided by 1 into 10 raised per 5. Number of moles of N2 you don't know. You can even skip it. You can just take the approximation here. You can take it as number of moles of H2O, because when you compare number of moles of H2O and solute and solvent, solute you can ignore also, right? So we can ignore, and if you see the options, here it is 10 mole. Here it is 10 raised to power minus 5, minus 10 raised to power minus 4, minus 6, minus 5. That means the number of moles of solute are very small, right? So you can also ignore it, right? So I can directly write number of moles of H2 is 10, and that's how you will calculate number of moles of N2, that is 0.8 into 5 divided by 10 raised to power 5. This will be multiplied by 10, and that will be your answer here, right? Okay, that will be your answer. You can calculate this. Answer will be 4 into 10 raised to power minus 5, and that is going to be your answer here. Is that clear to everybody? Right? Is that clear to everybody or not? Right? Okay. Yes, students. Right? This is what you will calculate. Right? Okay. Okay, so we have completed the target. The target was to complete solubility, right? Henry's law and Roults law. In the next lecture, we are going to do ideal solutions and non-ideal solutions. Okay, right? Now, students, I am asking you to just take the screenshot here, right? This is your homework. Okay, I want to see if you want me to take classes here on YouTube, I want to see the homework as well, right? Okay, because in the batch, students in discipline, they give the homework, this all the DPPs, everything they do, right? I am just giving you 2 questions. If that also you can't do, then guys, why am I even taking classes here, right? So this homework and this homework, I'll wait for your homework in the comment section, right? And if you're asking for any batch, right? I can see so many students when I was teaching, they were asking for, ma'am, is there any batch? Is there any batch? So yes, students, there is one batch, that is Sigma batch, in which we are teaching you live in the batch every day. Classes are going on there, right? In this batch, students, we are taking live classes, and if you're not able to see the live class, right, then you can see the recorded version, replay version, just like on YouTube. But in the batch, you can also ask the doubts in the replay version. And in the batch, like here, you have seen so many spammers were there. But in the batch, there is no spammer. There is full discipline that we follow in the batch. Moreover, we take quizzes, we give you leaderboards, DPPs, Tattva modules are given to you to give, like, solve modules, coaching modules are provided so that you can solve a lot of different type of questions. And moreover, students, along with that, we also take the mock test after every 15 days, and the frequency will increase eventually. And we also give you the test series, that is 40 part syllabus and full syllabus test, right? The link is in the description. It is 3,999 is the batch price, right? Now, everybody and all the students, you can also follow us on the Telegram channel as well. This is the Telegram channel. You can scan the code here, right? And you can follow us so that you get the live notification whenever we go live. You also be informed about that when we are getting live, right? And all the students, I'll be waiting for your comments in the comment section. What I told you, to do your homework, right? You have to do your homework, means you have to do 2 questions I have given you. I want all of you to answer me in the comment section, right? And for those students who are looking for the offline centers, then guys, right now, we are giving you IV SAT scholarship, where around after registering to that, you can get even 90% scholarship, right? And we are giving you guarantee rank improvement promises there, right? And if you are giving your IV SAT test, I would advise you to give it in the offline centers. And this is the list of offline centers here. You can call on the offline center, visit it, register yourself and give the test and get that 90% scholarship in your hands, right? Okay. Okay, so that's it. That's it, students. And see you all in the next class. That is for ideal and non-ideal solution. Till then, bye-bye. Take care. And I'm waiting for your comments in the comment section. Bye-bye.